So Susan Drew, EDAC, Market Segment Manager at Altro Americas, a graduate of the University of Alberta's School of Business with her evidence-based design, accreditation, and certification, and almost 20 years experience in the flooring and walling industry. Susan understands the importance of human-centered design and product development. In the past 7 years, she has collaborated with the A&D community and end user groups across North America, accumulating insight to the unique challenges of healthcare design, especially as it relates to behavioral mental health and senior care environments. Susan's passion is discovering and sharing with others solutions in the built environment that benefit our most vulnerable populations. What a topical subject, considering how many hospitals are being built across the country. Susan, the screen is yours.
Thanks, Chris. And thanks everyone for joining us today. I look forward to presenting this topic and look forward to your questions. I hope it's a lively conversation. I'm sure Chris will make sure that it happens that way. So some of the things that we're going to talk about today, we're going to talk about slips and falls. We'll review some statistics and costs associated with slips and falls. We're going to look at some guidelines and best practice around slip resistance. After that, we'll review some test methodologies used to measure both static and dynamic coefficient of friction. And then we'll look at a needs analysis that might help when you're trying to select that appropriate slip resistant flooring. So let's get started. I always like to start with some definitions. They may be very obvious to many of you, but it's always good to start this discussion on the same page. So falls. Falls occur when body movement shifts the body off the center of balance. Often happens because of slips. This occurs because there's too little friction between footwear and the walking surface, or because of trips. When a foot collides with an object, a trip can occur. It can also happen if the change in coefficient of friction is too extreme, and a trip can happen there as well.
Hey, Susan, question right away. Is there a point at which non-flat substrates become a trip hazard?
We're going to talk about that later, because flat substrates are a trip hazard.
Okay, gotcha.
So we will talk about that later. Slip resistance. Slip resistance is the relative force that resists the tendency of the shoe or foot to slide along the walkway surface. Static coefficient of friction. This is the frictional resistance one pushes against when starting in motion. So you're still and you start. Dynamic coefficient of friction is the frictional resistance one pushes against when already in motion. So why do slips, trips, and falls occur? Well, often it's because there's unexpected contamination on the surface of the material, such as leaks or spills, airborne grease and oil in the kitchens, soap scum in a shower, or dust and other contaminations in a dry area. It can also be other factors, things like wet shoes or poor transitions. And that might be, Chris, where that comment came up from, is how high is a transition? So maybe we can clarify that.
Yeah.
Where do they occur? Well, we often think of kitchens and bathrooms, even supermarkets, but really they occur everywhere. In general, thousands of people every day are hospitalized from slips and falls or injuries due to slips and falls. Slips and falls account for 30% of all reported US and Canadian injuries. Falls account for 10% of fatal accidents, and they contribute to 20% of non-fatal accidents. We know that slips and falls are some of the worst accidents that can happen in our aging population. I'm very passionate about this because of my background. Statistics state that 1 in 4 people over the age of 65 fall every year, and less than half of those people actually will tell their doctor. Just one fall can double an aging adult's chance of falling again. I'm not going to go through all of these numbers. You can read them yourself, but you can see how serious the consequences are. And before we move on, just an interesting fact from the work that we do in healthcare, most of the falls that we see in hospitals, I think it affects about 10% of total admissions. Most of those happen in bathroom spaces and affect younger, mentally healthy people. They're often traced back to medications and treatments is why they slip and fall. So it isn't just the aging population where the risk lays. There's a huge risk for population of all ages, especially within the workplace environment. Developed annually, this index ranks the top 10 causes of serious non-fatal workplace injuries by the direct costs, and this is a US index. If we combine the three categories, slips on a level surface, slipping and falling to a lower level, and slips without a fall, slips and falls represent 30% of all workplace injuries. And if you look at the largest of these categories, showing that 70% of these falls occur on flat surfaces in workplaces such as restaurants, hotels, supermarkets, as well as hospitals. I'm going to repeat that. 70% of falls occur on flat surfaces in workplaces.
And where liquid is concerned, like present, water? Or
Liquid, it can be dry contamination, seeds and flour makes a floor very slippery. So when we look at the total cost per year of these three categories combined, they add up to nearly $19.5 billion in direct US workers' compensation costs each year. So then if we make the assumption that in Canada, it would be about 1/10 of that based on population, it's still $2 billion per year or $400 million a week.
But this topic's lining the lawyers' pockets.
It's crazy. Yeah. OSHA's census of fatal occupational injuries was last updated in 2021, and identified 5,200 fatal work injuries. Obviously, transportation roadways are the leading cause of fatal injuries, but slips and falls are the second leading cause and account for 16.5 or 850 workplace fatalities a year. Most fatal falls are to a lower level, but 10% of those deaths occur from falls of 6 feet or less, meaning a simple slip and fall on a wet floor can still lead to death. So accidents do happen and they can be a major concern. So what should we take from this? Well, the best defense is prevention. It's what we can do. And although most of this presentation will focus on prevention and the topic of slip resistance and flooring selection, I do want to note that safety also involves some other considerations, such as durability. We want robust materials with high chemical resistant and long warranties installed with the correct adhesives. Chris, I put that in just for you.
Thank you.
We don't want worn floors or walls, creating tripping hazards or hygienic issues.
And we want drains properly detailed.
Yes, yes.
Like how many times do we see beautiful floor put in and just cut around the drain and siliconed because the wrong drain head was put in? It should be clamped and pinched down so that it's waterproof, grease-proof, cleaning fluid-proof, and lasts the lifetime it's supposed to. The alternative is just awful, and it's an ongoing problem. Every day we run into this.
I should put it on every slide, is what you're saying.
Exactly.
Yeah. Yeah, we want sustained slip resistance. We want to ensure that the life of the flooring, the material with their aggregate through and through the full thickness of the material and not just scattered on the surface. This is especially critical in wet areas or areas of wet cleaning methods, such as kitchens, where longevity and slip resistance is so important. When it comes to hygiene, we need to select surfaces that can be heat welded, thus considered monolithic, no seams or gaps that create traps for bacteria, dirt, mold, or mildew. We want that integrated floor to wall detailing right into the drains. And we want appropriate flooring transitions. We want properly selected and installed transitions, as these can be a huge tripping hazard if not handled correctly. And I'm going to assume that question earlier was what is considered a tripping hazard with regards to a transition. 1/8 of an inch, anything more proud than 1/8 of an inch is a tripping hazard. There are also some elements outside the control of the design and installation teams, such as regular maintenance. Flooring needs to be properly maintained in order for it to perform as expected. Regular maintenance in areas of heavy abuse, things like weld repair, can prevent a costly replacement down the road. Routine cleaning, without good housekeeping, any other preventative measure will never be fully effective. Safety flooring, for example, in a kitchen, doesn't have to be more difficult to clean, just different. With a mechanical scrubber, it's just a different pad. With manual regimes, it's just put that mop away and bring out a deck brush or a floor scrubber. It's not more difficult, just different.
So the wrong pad coming in off the corridor that then interacts with safety flooring it's not going to bother the safety flooring. It's probably just going to wreck the pad.
Probably just wreck the pad. And it's simple a matter of putting on the proper pad and going into the safety floor area, and it'll clean up really nicely.
Yeah.
You want to use the right chemicals too. There's specific chemicals for kitchen areas. They're a little bit higher pH. But the pad is the big piece.
Susan, got a question for you on the chat box here. Is there an industry standard that states a minimum 1/8 is a tripping hazard, or is that just it's a fact that trips can start at 1/8?
You know, the only industry standard that talks about that is ADA, and they accept, I believe, up to 1/4 of an inch. But the reality is, 1/4 of an inch, especially with our aging population, is way too much.
What is ADA?
American Disability Act.
Okay.
Yeah.
I know our standards call for 3/16 over 10 feet, which typically mirrors most manufacturers' guidelines for what they want for flatness.
For flatness, but an actual edge or transition strip that's put between rooms.
I see.
Need to be more proximity.
So a sudden elevation of 1/8 that you would get with the transition.
Yeah, maximum. Yeah, preferably none. Preferably no transitions would be great.
Yeah. Well, we have those construction joints where slabs stop and start, and those gaps must be on it all the way through the system. So inevitably you have a transition there.
Right.
So you want to be very careful where you place those if you're designing.
Exactly, and there's strategies to deal with those changes in elevation that we can work with and put it underneath the flooring.
That's useful. That's useful if you're trying to design those things and place them, and you actually have a solution in many ways to do that the best way possible. That's interesting.
Exactly. The other thing we always have to remember is footwear, because some shoes are just easier to slip in than others, even in ideal slip-resistant environments. So this demonstrates how risk management goes beyond just the design of the building to the environment itself, to maintenance and operation. So focusing back on the design of the built environment, let's have a quick look at some guidelines, best practices, and legal precedent around slips, trips, and falls. Here are just a few examples of groups that have published standards and guidelines around safety. The Canadian Centre of Occupational Health and Safety was established in 1978, and they use a council that represents government, employers, and labor to ensure there's a balanced approach to health and safety. There's the Occupational Safety and Health Act in the US, which is OSHA. It's the predominant employee safety organization for US workers, and we often look to them for some of their best practice. And Americans with Disabilities Act, which is the ADA, it's an important civil rights law that protects accessibility for all people. We often hear the question, well, what does OSHA or the ADA require for flooring slip resistance? How many people are familiar with this statement? Have you seen this on a specification? I want to know if you think this statement is true or false. If you can put it in the chat box, that would be great. I'd like to know.
Who's going to take a chance?
No. Should I sing like do do do?
I think we need to put up $20 for the winner.
Oh, nobody wants to answer. Okay.
There you go.
So this is false.
So we assume everybody just learned something.
There you go. So for many years, the industry has operated under the assumption that both OSHA and the ADA's recommendations advise a standard coefficient of friction, a static coefficient of friction of 0.6 or greater value on horizontal surfaces and 0.8 on ramps. The answer is that OSHA doesn't require anything, but nevertheless, they've caused a lot of confusion on this subject. So what happened was, in a non-mandatory appendix to a proposed rule in 1990, OSHA quoted a study from the University of Michigan that suggested that the 0.5 to 0.6 static coefficient of friction test for flat surfaces and 0.8 on ramps would be a reasonable measure of slip resistance, but it was never intended as a standard. In addition, the original report did not mention the test method, although it was assumed by the industry to be the ASTM C1028 test, which we'll review later. In actuality, the testing device used in the research was a force plate, which is not even a test used by the flooring industry. So because of all these issues, the reference to the study was removed shortly after the report's release. But to confuse things further, before this correction could happen, the static coefficient of friction OSHA statement was quoted by the ADA accessibility guidelines that were adopted as the ADA standards for new construction and alterations. So then as a result, it was accepted by many people as the industry standard for minimum slip resistance on flat floor surfaces and on ramps. So unfortunately, the reference remained in the ADA guideline until 2004, when for fear of liability, the ADA removed reference to any specific values. So in the 14 years between 1990 and 2004, many specifications used this reference and quoted these values. Today, we're still dealing with that legacy. I saw a specification not more than 2 weeks ago that still had that in there.
Those values were arrived at using a forced plate, did you say?
Correct.
Or the forced plate. Describe that for us. What is that test?
I'm not familiar with that test. I just know that it was never used for the flooring industry, but I could do some research on it for you, Chris, and so you could send it out to everybody afterwards. The bottom line, it wasn't an accepted test for flooring.
And that's different from the one that we discussed the other day, where you drag the plate across the floor, and that's supposed to be representing, the pressure of a foot, the randomness of a foot placement and weight displacement.
Correct. That's the James test, which we'll talk about in a minute.
Okay. All right. Yeah.
Yeah. So in summary, OSHA has never had an official slip test or safety standard for flooring. ADA has no reference to any specific values. And the Canadian standard simply states that to prevent falls, use appropriate non-slip flooring material. Wow. Some other guidance we often turn to is the CSA Z8000. It's a standard for healthcare because in healthcare, there's many areas like washrooms and operating rooms, emergency rooms, MDRD rooms that need slip resistant material. But all they state is that need to be slip resistant in both wet and dry conditions, as well as being durable and resilient and all those things. The FGI guideline, which is the US healthcare guideline, has very similar requirements to CSA Z8000. It just requires appropriate slip resistant flooring in all those areas. And then building codes may or may not offer some guidance. It really depends on the region you're in. But if they do, it may only refer to as adequate slip resistance. So the reality is that unless there's something specific in the local building code on this topic, it's really up to the specifier and the owner to determine the appropriate level of slip resistant for the space. So what does adequate or appropriate slip resistant mean?
Boy, the liability of being the specifier when you've got no guidance, and it's apparently on you. You chose to put that in the documents, and someone slips, and does that just all the fingers sort of point back to the specifier
and the owner? Yeah. It's stressful and it's confusing, and we all want to do the right thing and put the appropriate level of slip resistance into the space, but how do we determine what that is? And I will apologize to anyone who thought that I was going to give them that magic number today during this hour, because I'm not. I think what we can do is talk about due diligence, which gets into the legality and doing the right or appropriate thing, because it is important because of litigation and workplace safety issues. As mentioned previous, workers' compensation claims are one of the most recognized direct costs of slip and fall accidents. There's a lot of indirect and social costs as well. But, we were talking, what did I say earlier, $400 million per week between the US and Canada. It's a lot of money. Just some terms: cause of action. This is a legal phrase which means that the plaintiff should be able to prove a specific provable cause for the action, such as a slippery floor. Consultant liability is self-explanatory. Anyone who is selecting or specifying materials, architects, designers, specifying contractors, are often joined in a suit against an owner, where due diligence often becomes the defense for the consultant and the owner in these cases. If charged, an owner or specifier may not be found an owner or specifier may be found not guilty if he or she can prove that due diligence was exercised. In other words, the defendant must be able to prove that all precautions reasonable under the circumstances were taken to protect the health and safety of workers. And I do want to note that due diligence needs to be demonstrated by your actions before an event occurs, not after.
So part of the due diligence will be speaking to an expert, such as yourself, a company that specializes in non-slip flooring. All that would add up to the file that you're building to push back and say, I did due diligence.
Exactly. And then that's really, go ahead. Sorry, Chris.
I was just saying, just so it behooves us to really pick carefully who we're talking to about safety flooring.
Exactly. And slips and falls, as I said earlier, can happen anywhere. Just a few examples of some litigation. This is a case, it started in September 2015 when Eugenie Bouchard, she slipped and fell on an unknown slippery substance in a physiotherapy room. She was concussed and had to withdraw from the US Open. She sued for injuries and claimed negligence on the United States Tennis Association. It went to trial in 2018. And the two reached a settlement for an undisclosed amount. The USTA was found 75% negligent. So we'll be forced to pay 75% of the amount of the damages. They were never disclosed, but we're talking about, an athlete at her level and $1 billion industry. It was probably a large number.
And Eugenie retired early.
Yes, exactly. Another case, we talk about detergents. As detergent in a grocery store. In March 2012, a 48-year-old woman slipped on detergent that wasn't cleaned up in a grocery store. She hit her head and she suffered brain injury. She had headaches and dizziness, balance issues, a number of symptoms. It wasn't until 2018 that this case went to trial. Total damages exceeded $750,000. A lot of that was because of earnings that she wasn't going to be able to do or make, sorry.
So that's probably on a product like VC tile, which has no safety aspect built into it for friction.
Yeah.
Boy, the liability.
Exactly.
One smashed car, one smashed jar of pickles, and now you've got, $750,000 worth of cost around the corner.
And as I said earlier, it could be a broken bag of flour on the ground.
Right. You might not even see that with the VC tile being white, the flour being white, it disappears, an invisible hazard.
Exactly. Another case, it started in 2009. A 48-year-old man slipped down a set of stairs at an all-inclusive resort. He suffered a serious injury to his left leg and underwent surgery. In 2010, they went to trial, but it didn't settle until 2021, where the holding company was found 75% negligent. The man was also found 25% negligent due to alcohol consumption, but his damages still exceeded over $1 million.
Oh my God.
It's also a demonstration of how cases can drag on for years and years. At the time of trial, Mr. Klatt was almost 60 years old.
That case seems like if in doubt, sue.
Well, exactly. And anyone can sue. Anyone can make a claim for slip and fall. They have to show burden of proof. But, the courts do tend to favor the plaintiffs, and which is why many court cases settle outside of court.
Let's ask you a question here from KS. Is there any safety non-slip flooring that would stand up against liquid soap, or does that fall into the due diligence aspect?
There is, and you would use the same type of material probably that you would use in a shower, where shower gels and shampoos and conditioners would be present.
I've got another comment here. Liquid soap is like ice. It's just, next thing you know, you're upside down on the floor and you've got a concussion. You don't even realize what's happening.
Yeah, and so that's where the pros and cons and the due diligence comes in, is that we have to understand the programming in the space and what the risks are in order to put appropriate flooring in. There may be a decision to say, well, how often is liquid soap going to be on the floor? And, we'll decide if we want to take extreme measures or not, right? So it's a lot more often that you're going to have shower gels in a shower than you may have liquid soap in a grocery store.
So the basic approach would be the type of flooring that has particulate embedded in it.
Correct.
Protruding out of the surface, offering up some kind of grab or friction.
Through and through the entire.
Different types of that approach?
Yeah, there's different levels of slip resistance, which we're going to go into in a few minutes.
Better best, right?
Yeah, exactly. For each situation.
Mm-hmm.
As mentioned earlier, incorrect choice of flooring can mean that the designer, owner, and contractor can be subject to a legal suit and unexpected costs. So Again, I'm going to restate that it's because of increased litigation, increased insurance premiums, compensation claims, and design alone can never prevent all the accidents. Just like we just said, how often do you think liquid soap is going to be on the floor? But the expectation is that due diligence was made and it can be documented and be part of every design project. So things you said earlier, Chris, things like talking to someone who understands slip resistance, attending education like this presentation, understanding a manufacturer's slip resistant figures and what they pertain to, understanding the programming in the space and the potential of contamination on the surface of the material, discussion of that appropriate slip resistance, and then most importantly of all, documenting the risk management plan. Put it.
I wonder if when it comes to due diligence, if you were presented with good, better, best products from 3 different manufacturers and you chose good because it was the cheapest option, I bet you'd lose the case.
Yeah,
it wouldn't sound good as the defense lawyer.
Exactly.
Right?
Exactly. So talking about the tools that will help you do this, let's look at some of the testing and talk about some of those tools to help with due diligence. And Chris, I think you already mentioned this, but how does friction help prevent slips and falls? Well, we need to start with flooring that has good resiliency. It needs to give and then rebound. And then we add aggregate throughout the thickness of the material. So when the weight of the person is applied to the flooring surface, that flooring contracts and the aggregates grab the sole of one's foot to create friction. And this friction helps prevent slips. It's measured using test methodologies that either test the static coefficient of friction or the dynamic coefficient of friction. And we talked about those earlier.
So
go ahead.
So the grab is a combination of the protruding particulate and the extra resilience in the material, the softness of the material.
And I won't just say protruding particulate, because you can have slip resistant materials that all of the aggregate is inside the material itself, but when you step on the material, it gives and that aggregate comes up and creates resistance. So it's not protruding on the surface all the time. So it makes it easier to clean, but still slip resistant.
Right. So it goes to work when it's at work.
When it's needed. Exactly.
Right.
The static coefficient of friction since 1969 has been considered a reasonable standard of slip resistance in a surface, but since then, we've been moving more and more towards dynamic coefficient of friction tests, and we're going to talk about all of those. So there are a number of organizations that have test method standards: the ASTM International, American National Standards Institute, or ANSI, and DIN, which is the German Institute for Standardization. Here we can see the static coefficient of friction, the ASTM 2047, also known as the James test method. The RAMP test, or the DIN 51130, this is a dynamic test and very popular in Europe. The dynamic coefficient of friction, ANSI B101.3 or 326.3, also known as the BOT test. And the TTRL test, or ASTM 303-22, also known as the pendulum test.
So the BOT test is the ANSI test. That's the one in the top right-hand corner, right?
Correct.
And that's the one they just drag along the top of the surface of the floor.
And so in the James test method as well.
Okay.
Yeah. Sorry,
carry on. Yeah.
No problem. I will caution that when you're doing comparisons between materials, make sure you're using the same test method. It's especially with the dynamic coefficient of friction tests, there's a number of them. And if you don't have the same test method, it's hard to tell exactly which product yields that whole good, better, best. So you need to make sure you're looking at the same test method.
Seems like the RAMP test would be the most challenging one, or give you the most realistic results.
Yeah, and we're going to talk about the pros and cons of each one. So, we like the fact that, as the inventor of the safety floor, we test to all of them. We take safety and slip resistant testing very seriously. And so we're going to describe each one of those for you.
Because they test different scenarios, potentially. Mm-hmm. Yeah.
There's pros and cons to every test. There's no perfect test.
Yeah.
I mentioned earlier the ASTM C102807, which was the static coefficient of friction test. It was widely recognized to be inappropriate for assessing pedestrian safety. It gave false safe ratings to very slippery materials. and therefore in 2014 it was withdrawn. So if you do see this test referenced in a specification, please red flag it, and we need to replace that with a different test.
That's one I keep mentioning. The drag test didn't make any sense to me. Why that would be effective? So continue. Sorry.
So the ASTM D2047 is used for resilient flooring. It's been used since 1969, and it uses a device called the James machine. And this is what we were talking about. It pulls a small weighted sled over the floor surface. And the result is the measurement of friction the surface creates. Leather is the standard for this test, but we don't see very many leather soles anymore. So we test our products against neolite rubber, which is a material much commonly found on the bottom of today's sneakers and other footwear. The standard also does not call for wet testing. However, dry areas are really not where problems happen. So we test our materials to both dry and wet. And this is really good for informational purposes. It even provides comparison within our own portfolio. So we know which products are more slip resistant than others. The ASTM 2047 isn't the perfect test, as you've talked about, Chris, but it's the current accepted standard measurement of slip resistant for resilient sheet flooring products such as rubber, vinyl, and linoleum.
And still speaks to leather soles.
That's the standard test is a leather sole. Yeah.
Is that an indicator of how long it's been since it was updated?
Yeah, exactly.
1834 or something like that?
And there's lots of talk within the Resilient Floor Covering Institute about, maybe changing this as the standard, but nothing's happened yet. So
wow, I am shocked. That's amazing.
So that's your static. Let's move on to discuss the dynamic coefficient of friction tests. The first one is the DIN 51130, or what's known as the ramp test. It's a very popular test in Europe. And I'm going to run the video. I think I shared the sound. If I didn't, let me know, Chris, and I'll reshare. And I'm going to give you a break from my voice.
Glad to see this guy's in a harness.
Ramp test is used across Europe, and there are 3 versions of this test. EN 13845 Annex C provides an ESB and ESF rating on shoe and barefoot slip resistance using soap and water as a contaminant. DIN 51097 tests barefoot slip resistance when the ramp is covered with water. This gives an A to C rating. The third and most popular test, which we'll demonstrate now, is DIN 51130 and gives an R rating between R9 and R13. The test subject wears safety boots and walks on flooring that has been contaminated with oil. The ramp is inclined until the point at which the subject slips and the angle is recorded. The greater the angle, the greater the slip resistance of the floor being tested. R9 is the lowest rating on the R scale, with a slip angle of between 6 to 10 degrees. R1 to R8 do not exist. Therefore, R9 is the absolute minimum you should expect to see in this test. The R10 rating categorizes a ramp incline of between 10 to 19 degrees, R11, 19 to 27 degrees, R12, 27 to 35 degrees, and R13, 35 plus degrees. Altro has a range of safety flooring between R10 to R12 rating, which is designed to retain this level of slip resistance throughout the lifetime of the product. One of the benefits of the ramp test is that it uses a person to measure slip. All the other tests rely on machines. However, the shoe used in this test is a safety boot with a heavily cleated sole, which is not representative of general everyday footwear. Another limitation is that the contaminant is motor oil. Most slips occur with water. Finally, this can only test small sections of ex-factory flooring rather than monitoring how slip resistance changes over time with use in a real life.
There you go. So let's talk a bit about R values. So R values are a classification, not a test result. Values start at R9. This is a smooth floor, smooth. Each R value encompasses a broad scope of angles, as you heard. For example, R10 represents angles from 10 degrees to 19 degrees. This is a very large classification. There's a lot of materials that fall into this, and the materials at the lower end will perform much differently than those at the top end. So it simply provides us with a category, but it can be a very good starting point and helpful when used with other test methods that provide more specific results that we can dig into the specifics, for example, in that R10 category. The next test method is the ANSI B101.3. This test measures the wet dynamic coefficient of friction of common hard surfaces, such as tile. It's a portable machine called the BOT 3000, and it tests the dynamic coefficient of friction of any hard surface floor that you want to test. There is currently some controversy around this test methodology. ANSI B101.3 has lapsed and is being replaced by the ANSI A326.3. It is still a BOT test. And I'll quote what was said in the results of that test is that the BOT test is very useful. It can provide a useful comparison of surfaces, but does not predict the likelihood a person will or will not slip on a hard surface flooring material. Therefore, the BOT 3000 should be used in conjunction with the pendulum dynamic coefficient of friction testing, or ASTM 303-22, to help monitor changes in slip resistance.
Susan, keeping it topical here, George McCutcheon, he's asked, why is angle important in the DEN test? Max ramp is around 10%.
Because gravity is what's creating that pressure on the human body to force the slip, right? Without the other tests, we're doing movement, we're pulling a sled or pushing a sled, but there has to be some pressure and gravity, and the more you angle, the more gravity pushes. Does that make sense?
George, you can speak up if you need to voice the question. Does that satisfy you?
Yeah, I guess so. It has to do with movement then, right?
Mm-hmm. And that the gravity, the more the angle, the more gravity is pressure on the ramp.
Okay, thanks.
I know Skip Johnson's on this presentation, so I was waiting for him to jump in and help me out.
It's such a random topic that, due diligence adds up to just kind of covering as many bases as you can, and the possibility of slips from as many different methods of slipping that you can sort of identify and then try and build into your specification.
And that's why the ramp test is such a good starting point, because it creates categories, right?
Yeah.
And then from there, you can dig in, and do you need to be at the top end of the R10 category, or can you be at the bottom end, depending on what's happening in the space? But it's a really good starting point.
Yeah.
Okay, so let's talk about the pendulum test, or the ASTM 303-22. The pendulum test is the most widely used pedestrian slip-resistant test method worldwide. It is considered a national standard for pedestrian slip resistance in at least 40 countries around the world. It's been in use now for 50 years, which means there's safety criterion. It's backed by 50 years of research into actual slips and fall accidents. In North America, it was adopted by the ASTM in 1993. Used mostly for outdoor surfaces, interesting enough. It was reapproved in 1998 and then again in 2022. It's become, it's really the latest slip-resistant test method for assessing real-world slip resistance. And I'm going to give you another video to watch because I can't talk right now, and I need a break, I think.
The pendulum coefficient of friction machine is portable and can test the product at any time in situ. Although the test is used globally, it is especially popular in the UK as it is endorsed by the Health and Safety Executive and the United Kingdom Slip Resistance Group. The pendulum mimics the act of the heel striking the ground during walking. A specially formulated rubber slider on the bottom of the swinging pendulum arm sweeps across the floor surface and records the drag. As you can see, the pendulum test value on this dry Altro safety flooring is high. The higher the number, the lower the potential for slip. The pendulum test values are classified into high, moderate, and low potentials for slip. A pendulum test value of 36 plus gives a statistical value of 1 in a million chance of slipping on that surface, which is the minimum requirement for the HSC and UK slip resistance group to be classified as a safety flooring. If the floor is wet, a thin film of water is formed between the heel and the ground. This prevents the heel from making contact with the ground, and the heel can aquaplane and a slip occurs. In this demonstration, you can see a loss of friction with a wet heel and wet flooring. Now, when the residual water is dried from the floor but the heel is still wet, there is an increased risk of a slip occurring compared to dry conditions. This shows that walking on a dry floor with wet shoes also increases the potential for a slip. A similar result can be seen with other contaminants. Altro safety flooring has an aggregate that cuts through the contaminant and allows contact between the heel and ground to be made. Even with wet contamination, all Altro safety flooring for shod areas exceeds the 36 plus rating provided they are maintained correctly. Compare this to smooth vinyl and non-safety ceramics, which generate a pendulum test value of between 10 to 24 when wet. This equates to a risk factor of between 1 in 2 and 1 in 20 chance of a slip occurring. Let's use an example to demonstrate these risk factors. Would you cross the road knowing there is a 1 in a million chance of being hit by a bus? Probably, yes. But would you cross the road if there was a 1 in 10 chance of being hit? Altro safety flooring also stays slip resistant throughout the life of the product. An independent test on Altro Suprema 2 showed that after accelerated wear, which equates to 40,000...
We'll just move on. There we go. All right, so we've reviewed the different test methods. How do we determine the appropriate level of slip resistance? There isn't one solution that suits every environment, and there are many different degrees of slip resistance, as you saw. So the first part of the needs analysis is really about assessing what activities will be done in the space to determine, what's the contamination that we're expecting to see on the surface of the material to determine that adequate amount of slip resistance.
A quick comment that sort of backs up what you were saying from S. Johnson. There is nothing better than a small test area to determine suitability of a particular type of flooring for slip resistance in a particular area. In brackets, each area and use is unique. I think that's a great comment.
It is a good comment. Mock-ups are so important, aren't they?
Yeah.
So when you're trying to select the appropriate level of slip resistance for products, I like to go back to the pendulum test to help with this. And I'm just going to try to turn on my little laser pointer. So you can see this fit for purpose product selector, a number of different contaminants that we've tested to, as shown in that video, and then 3 different materials. And these 3 different materials, I just have to move, Chris, your video, because it's right in the way of my demo here. I'll do it over here. 3 different materials that we've tested. And this material here, it's a pendulum test value of 36 plus when tested with water. And that extrapolates to a risk of slip and fall in 1 in a million. So this specific material is perfect when you have water-only contamination, or, this example in a bathroom where there's no shower. This material is perfect. It could also be in an area that has just dry contamination, as we talked about earlier, like seeds or flour in a bakery, or on stairs, because typically you see water or maybe, other wet, some dirt brought in from outside. That being said, if we look at wet environments like showers, there's more than just water in these spaces, although we think that there's only water. There's also things like shower gels and shampoos and conditioners, like we talked about earlier, that whole liquid soap situation. So we need to get more aggressive in order to hit that 1 in a million chance of a slip fall. So this material tests with water at 50 plus, but it tests with these other contaminants at 36 plus. So areas typically we see are the barrier-free showers, or even areas that have both barefoot and shoed requirements. Now, if we go into an area where there's greasy water and vegetable oils like this, we need to go farther to the left to get even more aggressive. So, you know, this is typically in a kitchen environment, we'd have to have a much more aggressive material. You can see here, we like these perfectly detailed drains, Chris.
Love it.
So this is why we call it fit for purpose, as we want to ensure we don't over-engineer or under-engineer when making a product recommendation. There are many different categories of flooring within each category, many different types to choose from. This is a little bit of an eye chart. I apologize for that. But it just shows how it can make material selection very complicated and often confusing when trying to choose an appropriate material for a certain application. We do have this available if you need it, where you could make it a little bigger and have a look at it. I'm going to touch on just a couple of different materials that we often see chosen for slip resistance and durability. One is tile. It's a very familiar traditional aesthetic. It has really good design flexibility, great solution for both floors and walls, and it is a product that often gets specified for durability and resilience. Some of the cons, though, of tile is that the surface aggregate could wear away, leaving the surface very slippery. It's also susceptible to cracking and chipping on impact. Surface damage can harbor pathogens and excess moisture, which just creates other issues in the substrate. Porous grout between tiles is very difficult to clean. I did a presentation not too long ago, a couple months ago, with a designer. It's telling me that they've resorted to specifying gray grout on flooring applications, for public washrooms, for example. And they do that because that's the color it's going to enter.
You're still here?
So, you know, this isn't a solution, but just a way to mask the problem. It's, you know, I always go, I need to pause for a moment and consider what's turning that grout gray. Think about that.
Yeah.
And then it has poor acoustics and underfoot comfort, and when used as a flooring material.
This is from
epoxy. There's lots of pros to epoxy. It's generally robust, resistant to cleaning agents. It can be installed with different levels of slip resistance. There are certain types that are known for resistance to high temperatures, which can be great for certain applications. And if it's installed properly, it provides that monolithic resistant surface. The cons with epoxy is that slip resistant is part of the installation process, and if not metered out properly, can be very inconsistent. Over time, surfaces can develop micropores or pinholes, which catch dirt and bacteria and make it impossible to clean that floor.
So the challenge is on the installer to get it right.
It's all on the installer. Yeah. A moisture trapped in the slab can cause costly repairs. Again, installation is key to this resinous coating really bonding properly and being the floor that we expect it to be.
So if the installer offers up an inconsistent broadcasting of the particulate that's going to offer up the friction, now where does the lawsuit go? Interesting.
Vinyl flooring, you know, there is a full range of slip resistant flooring for a variety of applications. So depending on what you require, slip resistant is controlled at the factory under ISO controls. Some slip resistant flooring has aggregate through the thickness of the product, which does provide that slip resistance for the life of the material. It is naturally non-porous, and when it's heat welded, it prevents water ingress and pathogen accumulation. It's chemically resistant and inherently hygienic. It can endure high impact and heavy uses without surface damage. And the beautiful thing now is that with the acoustic flooring options, It not only minimizes excess noise, but it provides underfoot comfort, which can prevent the development of musculoskeletal disorders for people who are standing on their feet for long periods of time, like people who are working in kitchens all day long.
Is it all PVC vinyl?
Not all, majority of it is, yes.
There are options to avoid PVC.
Correct.
Okay. Okay.
Some of the cons is that some slip-resistant flooring only offers topical aggregate or textured emboss. So there isn't that aggregate through and through the material. It requires appropriate detailing. I should have put a drain drain detail in here but appropriate detailing and adhesive must be used in order to ensure successful installation. I guess installing a drain like it's in this picture is good enough for you, right, Chris?
You get me all excited now.
Yeah, there you go. Installation requires appropriate subfloor preparation, which you probably can speak to better than I can, but it's really important that all of that is done ahead of the installation of the floor. And it requires skilled installers for long-term durability. The installation is very important here as well. All right, so to review, when selecting flooring for your next project, there are a number of performance characteristics, including slip resistance, that need to be taken into consideration. We want to make sure we have durability. That impact resistance is really important. Look for commercial grades with long warranties. The products that are inherently that can be heat welded. We want stain resistance, chemical resistance, water resistance. Most of the really tough areas to put materials into need all of those. We want that integrated floor to wall detailing because it can't just be the floor and then the wall goes in and it wrecks everything in an installation, as you know, Chris. You have to have all of the proper details to make that completely water resistant space.
Yeah. You
need appropriate adhesives for the space. The material needs to be cleanable. It needs to be resilient and flexible and able to flash cove properly. You want to have the comfort underfoot that I just talked about. And then, of course, appropriate and sustained slip resistance.
And meet all of those ASTMs that we were talking about earlier.
Exactly. So in closing, I do want to just circle back to due diligence. As mentioned earlier, incorrect choice of flooring can mean the designer, owner, and the contractor can be subject to a legal suit and unexpected costs. We've discussed many variables, and we understand, I think, why meaningful testing is so difficult. And maybe that's why the guidelines are so vague. So when it comes right down to it, it's really about the dialogue between the designers, specifiers, and owners to promote a common understanding of what that design space is intended for, the risks of the programming to the people occupying the space. Whatever flooring you select, be sure to have the conversation with the owner about programming, surface contamination, cleaning regimes, and acceptable risk. Make a written note in the job file, or if appropriate, confirm in writing to close that loop on your due diligence. And with that, I'll hand it back to you, Chris, and say thank you.
Well, fantastic. Great information. Thank you. And well presented. We're really looking forward to adding this to our library. And I should just say, for anybody who wants to watch this video and all the others we do from month to month, just go to nfca.ca and roll your mouse over the education tab. You'll see the video library option pop up, and that's where you can go, no charge. It's all good information offered up to improve things in our industry. And Susan, you've done that today. Fantastic. Any questions from the audience? We got a couple of comments from Clayton. This was an excellent presentation. Thank you, Susan.
Oh, you're very welcome.